Howdy, my name is Michael Barris, and I'm a Principal Solutions Architect with the Amazon Relational Database Service. Today, we're going to be talking about the cross-region automated backups feature of Amazon RDS. This talk is intended primarily for Oracle DBAs and cloud architects who are looking to understand the DR capabilities of Amazon RDS. And out of this talk, we're hoping to learn three things. First, we're going to talk about recovery concepts, terminology, and metrics. We're going to look at how that terminology and metrics applies to Amazon RDS features and how to use those features to achieve your goals. And we're going to learn how to use the cross-region automated backups feature for recovery purposes. So quick agenda, we're going to start with a quick overview of Amazon RDS for Oracle for those who aren't familiar with it. We're going to talk about high availability and disaster recovery concepts and features. We're going to talk about the cross-region automated backup feature specifically, and then we're going to walk through the console steps for enabling and managing that feature. And then we'll leave time at the end for questions and answers. First, let's take a quick refresher on Amazon RDS. The Amazon Relational Database Service is a managed service that operates relational databases in the cloud. Started more than 10 years ago, RDS supports over six engines today, including MySQL, Postgres, and MariaDB, and commercially licensed software like Microsoft SQL Server and Oracle Database. It also supports the Amazon Aurora Cloud native database storage platform. RDS makes it easy to administer databases. Automation takes care of configuring instances in storage, installing and managing operating systems and database software, and simply presents you a database to connect to. RDS also has capabilities that allow you to create secure and compliant configurations, including network and storage encryption. RDS databases are highly available and durable, as we'll see in this talk today. And RDS also supports performant and scalable configurations, including compute scaling and storage scaling. One way I like to think about RDS is by comparing it to some of the other deployment models available. On premises, you have to manage everything from the dirt all the way up to the application by yourself. You have the physical infrastructure of data centers and servers, lifecycling that infrastructure, configuring and managing all the components all the way up to the database. By moving to Amazon Elastic Compute Cloud, virtual servers in AWS, AWS takes care of most of the infrastructure requirements for you, including physical data center security, hardware lifecycles, and maintenance. But once you have the virtual server up and running, you have to manage the database and everything above it yourself. By moving to RDS, a managed service takes care of the infrastructure components, as well as the operating system and database software installation and configuration, including high availability, backups, and scaling. This leaves application optimization, which allows you to focus on the application, schemas, data models, security of your data, and performance tuning. This is what really allows you to distinguish your applications from your competitors. When we look specifically at Amazon RDS for Oracle, we support Oracle Database version 12.102, 12.201, and 19c. We do support the versions of Oracle Database for which Oracle is currently providing critical patches and updates. So when Oracle stops supporting older versions, we do require customers to upgrade. For example, 18c was recently deprecated, as was 11.204 last year. Oracle customers have two license models to choose from. You can use the license included model, where you can run standard edition 2 workloads, where the license is simply included in the rental price of the instance. Under the bring your own license model, you keep your license and support agreements with Oracle, and you can run standard edition 2 and enterprise edition workloads in the cloud. You can choose EC2 instances with as little as 2 or as many as 128 vCPUs, and all the way up to 4 terabytes of RAM. Fast SSD storage provides storage up to 64 terabytes, as well as up to 4 gigabytes per second of total throughput, and up to 260,000 provisioned IOPS. Additional platform features include storage and network encryption, allowing you just to click a box and ensure that you've got your compliance taken care of. One trade-off of RDS is that because it's a managed service, we have to prevent you from breaking the database out from under the service, which would prevent us from keeping our promises. And so we restrict the database so that you have no host or sysdba access. Most applications are able to work within these constraints, but it is important to test your application and understand how it's going to work in the RDS model. Next, let's talk about some high availability and disaster recovery concepts and features. First of all, some terminology. When we talk about high availability, we're talking about keeping a system up and running continuously for your customers. We generally think of at AWS, we generally think of high availability as being an in-region concept to handle failures at the availability zone or at the server level. We accomplish this using synchronous replication and automated failover. Because we're replicating changes synchronously, no data is lost in a failover, and so it can be automated and recovered very quickly. On the other hand, disaster recovery is not just capabilities and features, but also the planning involved in understanding how to actually implement and execute those capabilities to recover from catastrophic events. We generally think of this as either complete loss of a database or, in the AWS context, a region-level failure. With disaster recovery, there's always some form of asynchronous replication involved, meaning whatever you press into service as a recovery option is not going to have the entirety of the data that was on the source system. And that means there is going to be some data loss available, and it's generally going to be a decision that you'll have to make. It will not involve automated failover. It's useful to have some metrics to look at when we're talking about these features, so we have a couple here. Recovery point objective, or RPO, has two contexts. In the planning context, it's the amount of data loss that you can tolerate in a recovery event. In a recovery or feature context, it's the amount of data lost in a particular event. So if your requirement is that you can only lose up to 1 hour of data in a region-level failure, then your RPO is 1 hour. Conversely, if a system experiences 1 hour of data loss, then that system experienced 1 hour of RPO. Similarly, recovery time objective, or RTO, has the same two contexts. From a planning perspective, it's the amount of time that you can tolerate for recovery to resume operations. From a recovery perspective, it's the actual amount of time it takes to recover from a disaster, or from a capabilities perspective, it's the approximate amount of time that we expect it will take. I like to think of it with this green line here, which shows the continuity of your application. We see that there's an orange dotted line here, which represents a break in that continuity, so some sort of failure that interrupted your application. RPO is the amount of data that we have to go backwards in time to restore the instance. So for example, if your database crashed today, and the only way you could restore it was from yesterday's backup, your RPO would be the amount of data loss between yesterday's backup and the failure when it occurred today. RTO is the amount of time it takes to get back up and running. So the orange dotted line is the time it took to get back up and running. In this case, the outage time for your recovery. So let's look at some capabilities of RDS and see how they help satisfy some of these. First of all, multi-AZ is our feature for high availability. By selecting multi-AZ for your instance, a second copy of your infrastructure is created in a second availability zone, and synchronous physical storage replication is used to transmit all of your changes. The infrastructure is fully independent, so failure of one availability zone does not affect another. And again, because we're doing synchronous replication, we can use automatic managed failover, and RDS also takes care of reinstating your previous primary to restore high availability after recovery. So when we think of this in terms of RPO and RTO, it has really the lowest because we're not losing any data, and failovers generally happen pretty quickly, maintaining the continuity of your application. There is a moderate cost associated with it because you're running more infrastructure that has to be licensed. In terms of DR, we have a couple options available as well. Backup and restore is the tried and true way of recovery for most configurations on premises. When you enable automated backup and recovery with RDS, RDS automatically takes daily snapshots of your instance at a storage layer, and then additionally, you can take extra manual snapshots yourself. RDS also automatically backs up archive redo logs to Amazon S3 every 5 minutes. With backup and restore, you only pay for the storage and data transfer costs until you actually perform a restore. And with RDS, backup costs are included up to the allocated storage of your instance. So for example, if you've created an instance with 1 terabyte of storage, 1 terabyte of backups is automatically included for free. In terms of RPO and RTO, these have higher values because restoring from a backup generally involves more data loss. And RTO because the time it takes to restore from backup is generally longer. It has the lowest cost because, again, there's no cost except the storage and data transfer until you actually perform a restore. Another option that we have is physical replicas. These can be either read replicas or mounted replicas. These are fully managed Oracle Data Guard or Oracle Active Data Guard configurations. Simply create a replica, and RDS does all the work of creating a standby and keeping it up to date with your primary. Replicas use asynchronous replication and can be used either in the same region or across region. You can have up to 5 total replicas per source database, and they could be a combination of read and mounted replicas or in-region or cross-region replicas. And in terms of DR, for DR purposes, You can promote a replica to become a read-write instance, or in Oracle terms, activating a standby database. This offers the lowest RPO and RTO because you have a warm database with nearly all of your changes up and running and ready to go, and can promote it in just a few minutes. It does have the highest cost, however, because you're running and licensing infrastructure. Finally, logical replicas are also used by many of our customers today in RDS. Logical replicas are customer managed, however. You can configure replication software for uni or bidirectional replication, and all your transactions or a subset of your transactions can send to another database, which can be Oracle, Postgres, or any other platform supported by your replication software and data and applications. Examples of replication software would be the Amazon Database Migration Service, Oracle Golden Gate, SharePlex, Stream, and others. This gives you full control over replication and application failover, but it does mean that you have to manage more of that yourself. This offers pretty moderate to low RPO and RTO, since you generally have, again, a warm, ready-to-go standby that can be pressed into service in a low amount of time. But it does have higher cost and effort because you're managing infrastructure that has to be licensed and also managing replication software. So if we compare all these options in terms of RPO and RTO, we'll see that, again, multi-AZ offers the lowest RPO at 0 because, again, with synchronous replication, we have no data loss, and an RTO of around 1 to 2 minutes for a failover. When we look at DR options, Snapshot Restore has an RPO of several hours, depending on how old the snapshot was relative to the failure, and an RTO of generally less than an hour. Point-in-time Restore has an RTO of several hours, depending on how long it takes to recover the instance, which is generally a matter of how many logs have to be applied. For cross-region, the RPO is usually going to be a little bit higher due to cross-region replication lags, around 25 minutes, but it may vary for your workload. In region, we expect the RPO to be around 5 minutes for all workloads. The other benefit of these capabilities is they're available for all editions, Standard Edition and Enterprise Edition, since they don't use licensed features of Oracle Database. In terms of replicas, we again have mounted and read replicas available, which both can be promoted in just several minutes. And because they're asynchronously replicated, but usually quite close to current, they also have a very low RPO, generally on order of seconds to minutes. These do require additional licensing, so mounted replicas require Enterprise Edition licensing, and read replicas require Enterprise Edition plus the active data guard option, so they do cost more. So what are some use cases for using these capabilities? Well, for multi-AZ, is what we recommend for most critical applications that require high uptime. This is going to be the high availability solution for most applications. You can configure multi-AZ on either your primary instance or replicas or both. And again, RDS automatically manages all the multi-AZ capabilities as a service. So automated failover and automated recovery from failure, including reinstatement of high availability after a failover has occurred. You also don't have to fail back in multi-AZ configurations because it's a symmetric configuration in both availability zones. Backups are helpful for recovery scenarios where you can tolerate a little bit more time and a little bit more data loss. This might be lower environments or dev test environments, or environments where you can recreate data from other sources. Backups can also be used to be copied to other regions, copied to other counts, to seed logical replication or other environments. Finally, replicas are something that we see customers use where you have applications that require really low recovery times and really low data loss, even in the face of cross-region failures. This does cost more because there's more infrastructure to run and there's more infrastructure to license. And it is limited to Enterprise Edition because it uses the Oracle Active Data Guard feature. But for customers that require those low recovery times and low data loss, this is the best option available. Now let's look at the cross-region automated backups feature. When you enable automated backups in RDS, a few things happen, automatically managed by the service. Daily snapshots of your Amazon EBS volumes are taken in a configurable window. This is generally going to be the overnight window for your region, but you can specify exactly when it should occur. There's a small performance blip right as a backup is initiated, but there's no ongoing performance impact. So we do recommend that this be in an overnight period, but you get to choose based on the requirements of your application. Additionally, archive redo logs are backed up to Amazon S3 about every 5 minutes. This allows us to be durable to S3 generally within the last 5 minutes at all times. And the oldest backups for the snapshots and the redo logs are automatically deleted based on the retention you specify, which can be between 1 and 35 days. When it comes to managed restores, you also have a couple of options. The easiest is just to restore a snapshot. Select a snapshot and choose restore, and it'll create a new instance that's in the exact condition that the primary instance was in when you took that snapshot. This is the fastest option because the EBS snapshots simply have to be restored as new volumes, and the database has to be started and then made available to you. It is always a new instance, so backup restore is never destructive and never replaces an existing instance. It always creates a new instance. Snapshots can also be copied to other regions, shared with other accounts, re-encrypted, and even upgraded. With a snapshot upgrade, generally used when the version of Oracle database covered by that snapshot has been deprecated, specify the new version you want to upgrade to, and RDS will automatically restore that snapshot into a sandbox area, upgrade the version of Oracle database, take a fresh snapshot, and replace the old snapshot. The second option for restore is point-in-time restore. With point-in-time restore, instead of specifying a snapshot to restore to, simply specify a point in time in your automated backup retention window down to the second. RDS automatically takes care of restoring the right snapshot and then applying archive redo logs until it catches up with the specified time and then opens the database and makes it available to you. Again, restores always create a new instance and don't replace the old instance. Point-in-time restore is available in the same region as the source instance and now in a second region as well. One thing to keep aware of for point-in-time restore is that the amount of time it takes to perform recovery is going to be a function of the amount of logs between the previous snapshot and the restore time. So for example, if you're using daily automated snapshots and you restore to Thursday at 4 p.m., RDS will restore the Wednesday night snapshot and apply Wednesday nights and Thursdays redo logs until it reaches Thursday at 4 p.m. and then make the instance available to you. If the amount of work covered in those logs is substantial, the amount of time taken can also be substantial, on order of several hours to even 24 hours for really, really hot workloads. So for some customers, we recommend daily automated snapshots plus manual snapshots throughout the day. The number of snapshots and frequency is going to be a function of your database workload and the RPO and RTO requirements for your recovery operations. By taking more frequent snapshots, RDS has more options available for restoring a snapshot before applying logs. In this example, we're still applying logs to Thursday at 4 p.m., but there's a more recent snapshot available, so we only have to apply the logs between 2 p.m. and 4 p.m. So the RTO is going to be lower. The specific RTO for your configuration is going to be a function of your application workload and the infrastructure that you've configured. So it's important to test it out and understand how it's going to respond to your particular workload and configure options from there. With cross-region automated backups, we've taken the automated backups that are available in a source region, and we've allowed you to simply replicate those to another region. When you enable the feature, you choose a target region and a target retention, which can be independent from the retention in the source region. RDS automation automatically does the work of copying snapshots and archive redo logs as they're generated to the second region. As new logs are generated, new logs are copied to the other region. Again, the amount of time it takes for this to happen is going to be a function of your database size and workload. As snapshots and logs are deleted from old regions when they've hit their retention, they're also deleted from the target region, and again can have an independent retention. All this allows you to restore to a latest restore time or any time in the retention period in the target region in the face of a disaster in the source region. So what are some use cases for this? Well, standard edition disaster recovery is one of the most common. For example, Enterprise Edition workloads can use read replicas or mounted replicas based on active data guard or data guard technology, but standard edition customers don't have that option. So cross-region automated backups are a great option for standard edition customers to have backups readily available in another region to restore when they're needed. Similarly, Enterprise Edition customers may choose not to use replicas for these use cases and choose cross-region automated backup instead. Single AZ and multi-AZ instances also can be complementary to this model, depending on the configuration and requirements of the database. And it also supports additional coverage for different replica configurations. So for example, you might have in-region replicas in the source region for read scaling use cases, but don't want to have additional replicas in a second region. Cross-region automated backups can take care of your use cases there as well. So in summary, Cross-region automated backups automatically copy your system and manual snapshots, as well as transaction logs, to a second region. You have independent retention in the replicated region and an RPO of typically around 25 minutes. RTO is generally a few hours, but it'll vary for your particular workload and use case, so it is important to test. Automated backups only cost for data transfer and snapshot storage, so they cost less than running infrastructure that has to be licensed either in the same or another region. Cross-region automated backups also support storage encryption, whether through Oracle TDE or Amazon KMS. So let's look at how to configure cross-region automated backups through the console. First of all, I'm going to be using the Ohio US East 2 region, highlighted here in blue in the top right of the console, for my source region. Later, we'll see the Oregon US West 2 region used as my target region. In the RDS console, I can choose databases, and I'll be given a list of my database instances available. I can select the instance that I want to configure and review its properties. By clicking the Maintenance and Backups tab, I can see the backup properties here. Highlighted, I've got automated backups enabled, set for 7 days retention in the source region, and I'm currently not replicating to another region. Automated backups are a requirement for cross-region automated backups. So if automated backups aren't enabled on the instance, they will be enabled first. And keep in mind that automated backups, when set to 0 days, run the database in no archive log mode. And that's great for loading environments where you're bringing in data that maybe can be restored from another source, or maybe ETL or other environments that are backed up and available in other ways. But for this feature, we'll need to have automated backups enabled. To enable cross-region automated backups, I'll choose Automated Backups in the RDS console. I'll look at my Current Region tab, which shows me databases in this region, select the database, and choose Manage Cross-Region Replication. Here I'll be given the option to enable replication, choose a destination region, and choose a retention period in that region, which again can be different. So in this case, I've chosen 3 days compared to 7 days in my source region. The list of destination regions is going to vary by each source region and is covered in our RDS documentation and in the console as well. Again, here I'm using Ohio as my source region and Oregon as my destination region. Click Save, and the replication configuration will automatically start working in the background. Here I see the cross-region replication configuration for this database. And as highlighted, I see that I'm replicating to the US West region now, and my replication retention period is set to 3 days. If I scroll down to the bottom of the page, I'll also see that system snapshots are already being copied. Again, the amount of time it takes to copy snapshots and redo logs is going to be a function of workload. Now it's time for point-in-time restore. Let's say I've had a disaster in the Ohio region, my database has been lost, the region has been made unavailable for some reason, or something else has occurred. Or perhaps I'm doing one of my monthly DR drills, which really help me understand how to use these features. Again, notice in the upper right corner, I've highlighted that I'm now in the Oregon region. So this is my target region. And if I look in the automated backup section, this time under the replicated tab, I see that I have replicated backups being sent to this region. If I click the database name, I'm taken to the properties for that database in the Oregon region. Here I see a few really important pieces of information. First is the earliest and the latest restorable time. This gives me the automated backup window that I can restore to, and I can choose any second within this window using Oracle's redo log recovery. Here I see the source region for this instance is again US East 2 in Ohio, and the backup retention period is 3 days. To perform point-in-time restore from the Actions menu, I'll click Restore to Point in Time. To restore to a point in time, I need to specify a couple important details. First of all is the latest restorable time. This is RDS has already figured out the most recent time that it can restore to, and this is basically the highest transaction in the most recent redo log that's been backed up to S3 in this region. I can also choose a custom time. So for example, suppose I've created a logical corruption by dropping a table from my database. I might want it to restore to the minute or hour before that drop was performed. But in this case, I'm going to use latest restorable time. I also need to specify an instance identifier for my new database. Remember, as we talked about before, restore always creates a new instance. And in this case, it'll have a new instance identifier and a new endpoint. Keep in mind, you can change instance identifiers after an instance has been created. So if this needs to be a temporary value and change later, that's totally acceptable. If I scroll down, I'll see that I can choose other configuration options for this database. I can choose the instance class, multi-AZ configuration, storage, and other components. Generally, I'll just keep the defaults, choose the restore time, and specify my instance identifier. Once I've selected all the values that make sense for my configuration, I'll click Restore to Point in Time, and the restore begins in the background. I'm taken back to the databases portion of my RDS console, and I see that the new database has already begun restoring and is in the creating state. Again, the amount of time it takes to go from creating to available is going to depend on when the snapshot was taken that restore is going to use, and how many redo logs have to be applied between that snapshot time and the restore time. So what are some best practices for using these capabilities? Well, the most important is to understand what your requirements really are, and really understand who owns those requirements for your application, and are they really right about them? What are the RPO and RTO that you really need for your application? It's tempting to say that everything always needs to be available, but there are costs associated with this. So it's important to understand the actual RPO and RTO for each of your applications. From there, take those requirements, look at the features of RDS, and use the features in your architecture that satisfy those objectives. If your RPO is 5 minutes of data loss in a cross-region failure scenario, you're going to have to run read replicas. Conversely, if your RPO and RTO are more relaxed, you can use cross-region replication. The most important part of any disaster recovery planning is testing it. You always need to have gone through the recovery scenarios to understand all the steps that you're going to need to take, and all the little gotchas and issues that you're going to run into. So don't just create runbooks, but also run game days to go through those configurations, go through those restore scenarios, and actually understand how these restore scenarios are really going to support your requirements. And finally, you can use cross-region automated backups as a lower cost recovery option in the second region. Because there's no running infrastructure, you're again only paying for data storage and network transfer. So let's look at what we've covered. First, we've talked about recovery concepts and terminology and metrics. So we now know what high availability, disaster recovery, RPO, and RTO are. We've looked at the RDS features for supporting these capabilities. So we've talked about how multi-AZ supports high availability, and we've talked about how backups both in-region and cross-region, as well as replicas, can support disaster recovery. And finally, we've seen how to use and configure cross-region automated backups for disaster recovery. So what are some next steps? Well, check out the aws.amazon.com/RDS documentation pages to learn more about the RDS service. You can also look at our documentation to learn specific information in our user guide about how to use RDS and how to implement some of the features we've talked about here. Finally, we really recommend you take a look at our database blog, where our experts have written great articles on how to use these capabilities for your specific use cases, including the two-part blog series we wrote on managed disaster recovery with Amazon RDS for Oracle cross-region automated backups that covers the material we've talked about today. Thanks for your time, and now we'll take your questions.